In this video, we're going to differentiate using basic differentiation rules. So let's go ahead and go over a few of those right now. The derivative of a constant is going to be 0, no matter what that constant is. The derivative with respect to x of x, or the derivative of t with respect to t, any variable with respect to itself, is 1. The derivative with respect to x of x to the n is n x to the n minus 1. If I have a constant multiplier in front of that x to the n, like so, then it'll be c times n x to the n minus 1. We'll just multiply coefficient times exponent, drop the exponent by 1. If I have multiple terms added together, and I'm just going to abbreviate that as f of x plus g of x, then we'll take the derivative of each piece of each term, term by term. We'll abbreviate the derivative with this prime notation, plus g prime, like so. And if I would have subtraction instead of addition, then I would have f of x minus g prime of x, f prime of x minus g prime of x. I'm not going to get into products or quotients here unless they come up in the problems. I don't think they will. We'll be dealing completely and totally with the power rule in this section from what I've seen. So let's go ahead and just work on these right now. This is a special case of the power rule because for any constant, it's an x to the 0 power. So then 0 times anything is 0. That's why that's 0. This is to the first power. It's a special case of this rule. 1 times the coefficient of 1 is 1. Drop the power by 1, it becomes x to the 0, which is 1. 1 times 1 is 1. And so let's go ahead and get started with these problems in 2.2. Go ahead and erase these rules. I think you have them written down and you can reference them from your notes. So 2.2 number 1 is y is equal to 3. Well, that's a constant function. So the derivative of a constant is 0. Number 3, y is equal to x to the 5th. So we're going to use our power rule here. Y prime is going to be 5 times 1 is 5. Drop the exponent by 1. Let's go ahead and write that here. 5 minus 1 is 5x to the 4th. Number 5, h of x is equal to 3x to the 3rd. That's going to be 3 times 3, x to the 3 minus 1. 3 times 3 is 9. X to the 3 minus 1 is 2. Number 7, y is equal to 5x to the 4th over 6. I'm going to write that as 5/6 x to the 4th, just so it looks closer to what we had for our rule. So y prime is going to be 5/6 times 4x to the 4 minus 1. That's going to be 4 and 6 have a common factor of 2. 5 times 2 is 10. Denominator here is 3. X to the 4 minus 1 is 3. If I want to write that back how it started off, it's 10x to the 3rd over 3. Go ahead and turn the page here. We'll be on number 9. F of x is equal to 4x. So f prime of x is going to be 4 times 1 is 4. Drop that exponent by 1. Number 11, y is equal to 8 minus x to the 4th. Sorry, x to the 3rd. So y prime is going to be the derivative of 8 is 0 minus the derivative of x cubed is 3x to the 3 minus 1 is a negative 3x to the 2nd. 13, f of x is equal to 4x squared minus 3x. F prime of x is going to be 4 times 2, x to the 2 minus 1, minus 3 times 1, x to the 1 minus 1 is 8x to the 1st. I don't need to write a first power. Minus 3, x to the 0 is 1. I don't need to write that. Number 15, f of t is equal to a negative 3t squared plus 2t minus 4. F prime of t is 2 times negative 3 is negative 6. T to the 2 minus 1 is t. 1 times 2 is a positive 2. T to the 0, that's just a constant. The derivative of the constant is 0. One more problem here for this video. And that's going to be number 17. S of t is equal to 4t to the 4th minus 2t to the 2nd plus t plus 3. Just more terms, but we're going to take the derivative term by term. 4 times 4, t to the 4 minus 1, negative 2 times 2, t to the 2 minus 1. Derivative of anything with respect to itself is 1. Derivative of any constant is 0. So 4 times 4 is 16. T to the 4 minus 1 is 3. Minus 2 times 2 is 4. T to the 2 minus 1 is 1. Plus 1 plus 0 is 1. All right, that's it for this video. We'll come back next time and talk about finding derivatives by rewriting the with negative exponents, fractional exponents, things like that. So rewriting things that don't look basic into this basic power rule, and then differentiating with respect to it. So we'll pick up a couple of different sections of problems, both rational functions and radical functions that can be rewritten. And we'll do that in a multi-step process using a small chart. And so let's come back and talk about that in the next video. See you next time.